Yeah, beta, as I told you already, that yesterday we were working on the problems in which we are given with the statement, we are given with the reasons. We have to just to guess that which reason it was applied to get the step, right? And
Yeah.
today, and today it's going to be more interesting and more mathematical, more logical, that we are just given with the statements. And by using the statements, what we have to do, we have to prove them, okay, by using the two-column proof method, okay.
Mhm.
So the things that we learned yesterday and the day before, we will try to apply them, and we will try to get more. We will try to prove the theorems, the results that are quite easier. Usually we learn them, we say that this equals to this, but how logically? Okay, we will try to develop the logics now that there is a mathematics behind that. Okay, if you look at this question, what it says in question number 5 to 10, name the property that the statement illustrates. So we are given with the statements and we have to name the property. This is very easy and very easy question. Look at the first statement. If the segment PQ is congruent to the segment ST, if segment PQ is congruent to the segment ST, and segment ST is congruent to UV, okay, so these are the two conditional statements. If these two are being satisfied, then the segment PQ is congruent to UV. So which property is that? This is a property, we call it transitive property of,
Congruency.
yeah, transitive of congruency. Okay, this is the transitive property of congruency. Is it clear?
Mhm.
Look, angle F is congruent to angle F. Which property is this? Every angle is, this is a self-congruency. So this property is called reflexive property of,
Congruency.
yeah, this is the reflexive property of congruency. Okay. In question number 7, you said if angle G is congruent to angle H, then angle H is congruent to angle G. Which property is this? This is the symmetric property of congruency, okay? Is it clear?
Yes.
Okay. Then in question number 8, it says that the line segment DE is congruent to the line segment DE. So this is again a self-congruency, but this is the reflexive property again. Property of congruency for line segments. Okay, this is a reflexive property of angles, reflexive property of um, congruency of line segment. Okay, I think there is already a very short space, so I can't write it. But did you get it? This is a reflexive property of congruency of line segments. Clear?
Mhm.
Okay. In question number 9, it says that if the line segment XY is congruent to the line segment UV, then UV is congruent to XY. This is symmetric property of congruency of line segment. Okay, it is an analog of Question number 7. It was for angles, and this is for the line segments. And in question number 10, it says that angle L is congruent to angle M, and angle M is congruent to angle N, then angle L is congruent to angle N. So this is again the transitive property, okay, for angles. Clear?
Mhm.
Yeah. Now, very interesting and very important. Look at question number 11. What it says? It says that we have to prove this result. Reflexive property of segment congruence. What does it mean? So, what is the reflexive property? The reflexive property is that if we are given with the segment LU, then it is congruent to LU. Okay, this is what we have to prove. Okay, but what we are given with? We are given that LU is a line segment. Okay, LU is a line segment. So we have to prove it with the help of a two-way congruence, a two-way column proof. Okay, so what is the way? First of all, what is the structure of the two-way uh, column proof method? On the left side, we have statements, and on the right side, we have reasons. Okay, now the first statement that I am writing is that LU is line segment. LU is the line segment. And how I got that? It was given to me, right? I assume that LU is a line segment, so we will say it is given. Clear? Now, if LU is the line segment, then it will have some length, right? So we'll say that LU is a length of, just take it instead of LU, let's replace it with M. That M is the length of line segment LU. Okay, so this is just by using the definition of length of segment. Is it clear? I name that M is the length of the line segment. Clear? Now, if I say M is the length of the line segment, that means M would be, let's say, it is 2 meter, it can be 2 centimeter or 1 meter, whatever the length. If you look at these numbers are real numbers, even though these are um, non-negative real numbers. Okay, so the length of any line segment is always a non-negative real number, right? And in real numbers, we know that the real numbers are symmetric. Sorry, the real we are proving the reflexive. So the real numbers are reflexive. So I can write m equals to m by the reflexive property of real numbers. Okay. Is it clear how I write this statement? This is very important. Got it?
Mhm.
Okay. Now, if m is equals to m, that means now I can substitute, or I can write it generally, that LU is congruent to LU by using the congruence definition of length. Okay, definition of C of segment. Okay, so that's it. We finally proved that LU is congruent to LU. Is there any confusion? You can see the whole proof. Okay. If you have any question, you can ask. I will explain this to you. These questions are very important and very interesting at the same time. That you are given with the statement, you have to write the statements, you have to use them with the help of logics. So by using just four statements, would prove that the congruency of the segment is a reflexive property. Okay. Please look at it and tell me if you have any confusion. Okay. Just take 1 minute and just look at this in total. Beta, is there any confusion?
No.
Okay, all right. Now let's look at the next question, which is question number 12. What it says? It says that this is question number 12. What we have to do? It says that we have to prove the transitive property of angle congruency. Okay, we have to prove the transitive property of angle congruency. What does it mean? What we have to prove? That if, first of all, in angle congruency, we are given with some condition, and then we will get a conclusion. So we are given that, let's say angle A is congruent to angle B, and angle B is congruent to angle C. This is what we are given. Okay. And what is our target? What we have to prove? That angle A is congruent to angle C. Clear? This is what we have to prove. Now see how I can prove. We will prove that. On the left side, we will have statements, and on the right side, we have reasons. Okay, is it clear? So, the first statement that I am writing is that angle A is congruent to angle B. From where I got this statement? This is my first statement. I got it because I was given with that, right?
Right.
Okay. So if they are congruent, that means uh, measure angle A equals to measure angle B. So this is the analog of the congruency. Okay. So by congruency to equality, how we move that? By definition of congruence. Is it clear? At the same time, I was given that, this is my third statement, that angle B is congruent to angle C. I was given with that. Okay. Now again I can write that measure angle B is equals to measure angle C by definition of congruence. Is it clear?
Yes.
Okay. Now, if you look at the when we write the measure, it is the equality property now. Now, equality relation is congruent. Okay. So I can write that measure angle A equals to measure angle B and measure angle B equals to measure angle C. I got it by the statement 3 and by statement 4. Okay. Then this is 5 and this is 6. Okay. Then from these two, I can write measure angle A equals to measure angle C by transitive property of equality. Is it clear? Because in equality, the transitive property holds, so I can write it. Clear? So if they are equal, that means the next step I can write that the angle A is congruent to angle C by definition of congruence. Okay, so that's how we can prove that. We got that this is a required result that for which we are looking, and we have to prove angle A is congruent to angle C. You can see it in the beginning that's what we have to prove. So look at the proof of this question, and if you have any question, you can tell me. So this is how, by step we can prove any result. Okay, please quickly look at it. You have a minute, then we will move to the next question. If you have any question, you can ask. So is it clear, Dion? So beta, is it clear?
Yes.
Okay, if it is clear, then look at question number 13. I'm solving it here. Can you see where I'm solving it? Please reach out to that point. Also, look at the question, what it says. It says that given angle, the geometry is very important for this one. The angle GFH, GFH. This angle is congruent to angle GHF. GHF means these two angles are congruent. Then prove that angle EFG, which I am going to highlight with the green color, EFG, this angle, and angle GHF, GHF, this angle, they are supplementary angles. They are supplementary angles. What are supplementary angles? If their sum is 180. Okay, so that's what we have to prove. Is it clear? Is it clear, Rita? Uh, is there any confusion or is it clear?
No.
Alright. Okay. Now, how we will prove this result? So, first, let's write the statements here. And we will write reasons here. Okay. Now, if you look at this diagram, the point E, F, H, they lies in the same line, right? So I can say that the point E, F, H are collinear. Okay, these points are collinear, and how I got that? I got this with the help of diagram. Clear? Is it clear? Okay, so if it is clear, then you can see that FE is a ray, and at the same time FH is also a ray, and they have a common point which is F, and they are opposite rays. So I will say that FE is a ray and FH are opposite rays. Is it clear? How I did that? By using the definition with the help of the diagram and by using the definition of opposite rays. Is it clear? Is it clear?
Yeah.
Okay. Then look at the angles. Now I will try to make an angle, both angles at this point. So angle EFG, angle EFG and angle GFH, angle GFH, they are supplementary. They are supplementary. How can I say that they are supplementary? Because um, they are on the same point and they are constructed by the opposite rays, and this is basically a linear pair postulate. Okay, so why they are supplementary? First of all, I proved that FE and FH, they both are opposite rays, and the ray FG is the angle EFG and angle GFH. They have a common sharing point and they lies on the opposite rays, or they lies on a same line. So that's why they are supplementary angles. Okay. If they are supplementary angles, that means their sum is 180 degree, right? So I can say that measure angle EFG plus measure angle GFH is equals to 180 degree by the definition of supplementary. So this is by definition of three angles. This is by the definition of supplementary angles. Is it clear? Is this statement clear to you?
Yeah.
This statement is very important. We will also use it further. Now we are given that angle EFG is congruent to angle GHF. So angle GFH equals is congruent to angle GHF. It is given to us, and then when we are converting the congruency to equality, we can write them that measure angle GFH equals to measure of the angle GHF by definition of congruency. Okay. Now look, this is very important and very interesting. Measure angle GHF is equals to the measure angle GHF. GFH is equals to the measure angle GHF. So I will substitute this value here. Okay. For this one, I will substitute this value. Okay. So by substituting the values, what I will get? I will get measure angle EFG plus measure angle GHF equals to 180 degree by substitution. The reason is I substitution property of equality. Okay. So what I proved? I proved that the angle sum of EFG and the angle sum of GHF is 180 degree. So they are supplementary. So hence proved. Okay. So that's it. That's what we have to, that they are supplementary. Is it clear?
Yeah.
Okay. Just take 2 to 3 minutes to look at this problem. Okay. And then we will prove, we will take the next question, some other side, and we will try to prove that. Please quickly look at the question. So, is it clear?
Yeah.
Okay. Now please look at the next problem. It's question number 14 that I'm going to solve here. Can you see? Here I'm going to solve it. Please reach out here. Okay. So, do a bit look. What the question says now? It says that given the segment AB is congruent to FG, which one is AB? From this point to this point, it's AB segment, okay? And it is congruent to FG. From F to G, it is congruent, okay? And then the ray BF bisects AC. So if BF, this line is bisecting AC, that means B is the midpoint. Okay, if it is passing through the midpoint, that's why we say that it is a bisector. Okay, bisect means it divides it into two equal parts. Clear? At the same time, it also bisects DG, that means F is midpoint. Is it clear? Is it clear?
Yeah.
Okay, then what is our target? Our target is to prove DF is congruent to BC or BC is congruent to DF. Okay, now let's see how we will complete this proof. So here I am going to write statements, and here we will write our reasons. Okay, now the first sentence that I'm going to write is about that BF, the line BF is it bisect AC and DG. So BF ray bisects AC and DG. So it is given. Okay, this that means point B is midpoint of AC and the point F is midpoint of DG. Is it clear? Because it is the bisecting. The line is bisecting them. If it is bisecting, that means it is passing. They are passing through the midpoint. Okay. So this is by the definition of bisector. Clear?
Yes.
Okay. Now look here. If B is the midpoint, that means AB is congruent to BC. Okay, because B is midpoint. Got it? Similarly, as F is the midpoint, that means BF is congruent to. Um, okay, instead of writing it further, we can write it in terms of the equality that AB equals to BC by the definition of congruency. Okay. Similarly, F is the midpoint of DG. That means BF is congruent to FG because F is midpoint of DG. Okay, and
Mm-hmm.
by the definition of congruency, we can write BF equals to FG definition of congruence. Is it clear?
Yeah.
Okay. Now at the same time, we are given that AB is congruent to FG. At the same time, we are given AB is congruent to FG. That means it is given. So we can write AB is equals to FG by the definition of congruence. Is it clear?
Mm-hmm.
Okay, now look. AB equals to FG and at the same time AB is equals to BC. I am highlighting this one and this one. Let me name it. This is 1 and this is 2. So I can apply the transitive property now, right? You can name it that in this way, that BC equals to AB by using the reflexive property, and then AB equals to FG. So we can write BC equals to FG. Is it clear? By using the transitive property. So by applying the transitive property, we can have BC equals to FG by transitive property, and point number 1 and 2. Okay. Now look at, let me name it 3. Look at this 3 sentence and this one. I name it 4. Again, it's, you can see FG is same on the right side, so their left sides will be equal. This is basically the transitive property again. So again, by transitive property, I can write df equals to dc by the by transitive property of equality for equation number 4 and 3. Okay, so finally I got that df is equals to dc. If df is equals to dc, that means their corresponding segments are congruent. So I can also write it as, because we have to prove dc equals to df, so I can write it as bc equals to df by using the reflexive property. Then I can write BC is congruent to DF by using the definition of congruence. Okay, so hence we prove. Is there any confusion?
No.
Look at this complete lesson. Okay, that's good. And it's enough for today.